All right, welcome back. Like I said, we're going to start talking about 6 different types of quasi-experiments here. And I wanted to use a specific example for this. And one that pops to mind for me, I do obviously lots of work that has to do with racial stereotypes and racial attitudes. And I do some work that has to do with like the legal system and law enforcement. So one example that comes to mind for me, rather than always using my kind of boring examples of like math and writing instruction and stuff, let's use an example instead with a serious social problem that in some municipalities, police officers in different places might be likely to shoot unarmed people, generally that are people of color or other minority groups. So very serious topic, obviously, one that we might reasonably be very interested in reducing, that we want to see that there isn't a racial disparity in the shooting of unarmed subjects. Ideally, there would not be any shooting of unarmed subjects, but we would especially want to make sure that there's not a systematic type of bias going into that. So maybe to reduce that, one idea might be that we would have a special kind of weapons training that includes aspects of, the structural discrimination faced by people of color and the racial sensitivity types of training that, might be efficacious in some ways. So let's say we have a control group, people just getting normal type of weapons training, and an experimental group, treatment group of people getting weapons training with racial sensitivity aspects to it. So we want to test whether those might be differently impactful on these types of outcomes for shooting disparities. Okay. So let's go through all these different types and what those might look like for that particular example. I've talked about obviously one type of quasi-experiment more than others, this non-equivalent control group design. So do remember that that's the one I've kind of been talking about with pre-existing groups and using a treatment and control. But do note that there are lots of these other different types of things that we're going to go through that do qualify as quasi-experiments. So when I say a one group post-test only design, thankfully a lot of these names are pretty self-explanatory, so they're pretty easy to identify what they're like. For a one group post-test only design, you don't have a control group. You just have one group that receives a treatment, and then you measure your dependent variable. So in this scenario, we might see that we've identified some group of law enforcement officers. We've given them the weapons training with racial sensitivity aspects, and then we have measured the disparity or lack thereof in their shooting of unarmed suspects to see if there is a racial disparity there. So did the treatment lead to a good outcome? So obviously there are many problems with this and how you might make an inference that you have nothing to compare it to. You don't have a control group, obviously, so you don't know if the treatment is better than some alternative, like a normal weapons training. You also, very importantly, really lack internal validity because you don't have a baseline or a control group. So if you don't have anything to compare this to, what can you say about what this outcome means, right? It could just mean that this is what would have happened anyway, or maybe your training made outcomes worse. You really can't know from this type of design. So while it might be useful to just do measurement in general, having no comparison means that you can't really say anything about what the potential effect of this treatment really was on a dependent variable. You don't know if it's better or worse, how it compares to a control group. There's just really no inferential basis here. You might use it just to be able to describe what's going on, but there are lots of caveats about what it actually means. So as we go through these, you'll see that we're kind of stepping up the level of rigor every time with the types of comparisons that we can make. So what's one level of rigor up from a one group post-test only design? Well, it would be a one group pre-test post-test design. And it is just what it sounds like. You would measure, let's say, the racial disparities in unarmed suspects being shot in a particular place or municipality or a law enforcement group. Then you would give them the treatment of the racially sensitive types of weapons training, and then you would measure things again. And then you would see, does this baseline differ from the outcome, and can we say something about the treatment there? So the plus side of this is that you're adding some sort of comparison. You can compare the outcome to the baseline and see that the treatment interceded there. So you can measure something about change by looking at this series of events. But it still has lots of issues that you can't rule out lots of alternative explanations here. The threats to alternative validity here and the alternative explanations that kind of go hand in hand in a lot of ways are that you might have historical things that are going on here in the middle that are leading to these changes in DVs. Maybe in the middle of this, there was a very highly publicized shooting of an unarmed black teen, and it made people in this particular place be much more careful about shooting suspects. Maybe they just weren't doing it in general, so the disparity seems like it's gone down. It might then be that the treatment had nothing to do with it. It's just that something in the national consciousness in the middle led to people being more careful and shooting fewer suspects. So the change might be totally because of things outside of the study. And when things are totally outside of the purview of the study and how you think the IV and DV are related, then that is a big threat to your internal validity, of course. There might also be maturation. In this particular example, maybe we have a really young police department where the officers are, not as trained as some others might be. And so maybe it's just the case that they're all getting better at using their weapons and at being judicious in how they are doing it and being fair. So maybe the treatment happened, but maybe over the course of this, let's say it's a 6-month period, all of the young police officers are just getting better at their jobs, so the disparity lessens over this period of time. So there might just be individual level changes that are amassing because they're all just getting older and more experienced and better. Testing could be a problem here. Remember, that's just being affected by being measured. So maybe assessing things in your police department, maybe it's not necessarily that we're just looking at the rates of shootings, because maybe that's not a good way to measure this. Maybe you give all the officers in a police department a type of shoot, don't shoot game, like they might use in a psychological study looking at shooter bias. And you give all the police officers in a particular area this shoot, don't shoot task where they're, very aware probably that they're being, there are comparisons being made to the white and black or persons of color that are in the game. Depending on where it is, it might be more appropriate to use not just only black suspects, but other people of color, so it's more realistic. But it might just be that by being measured, they're all going, hey, people think we're racist. Let's try not to be racist in how we're applying our, the aspects of our job that we're doing. So they all work harder at being more equitable and being more careful about how they are treating people. So they have a baseline that's not great, but they get better because they're all just trying because they were tested. So this might be, some kind of difference that is happening just because they are motivated in some way because their attention has been drawn to this aspect. Instrumentation, I guess in all honesty, the way that I have, chosen my example here doesn't lend itself super well to instrumentation, but let's say there is a big influx of people of color to a particular area, and you're just looking at baselines here in disparities. Maybe because you're just measuring shootings of persons of color compared to white people, and there's a big influx in people of color moving to an area, that this thing is going to change just because of demographic changes. Well, that's kind of also a problem with the way that you're measuring the disparity, right? Maybe you need to think of it on a per capita basis rather than just a like percentage of total shootings or something. So it might be that the way that you're measuring it isn't appropriate over time, and you need to reassess things like that. And of course, last one I have here, regression toward the mean, one that's a little more self-explanatory. Maybe when you measured their level of racial disparities in that shooter bias game you had, you just happened to measure by total random chance something that was very extreme, and then you extreme in a bad sense that more is a bigger disparity. Then you do your treatment, and then you measure it again, and out of that theoretical distribution, you just happen to get something closer to equal. So it might just be that one of these measurements is unlikely, and that artificially makes you think that your treatment is having some sort of change. So all of these issues are still possible with this type of study. So what are some other things we can do to try to reduce those sorts of issues and have a better position to make inferences about the effect of our treatment? Okay, sorry that I went through those things already. Here are obviously some other ways of phrasing some of the things that I said, but I'm not going to go through all of them again right this moment, obviously. Okay. The next way we might try to assess this, that is up a level of rigor again, is to actually make comparisons between two different groups. Rather than making a baseline and then a comparison after a treatment, maybe we want to use non-randomly assigned groups. So again, this comes back to my example about like the different sections. Our non-randomly assigned pre-existing groups, and we might have a control version and a treatment version. So it would look something like this. One group gets no treatment, and you just measure the DV. Another group looks just like our one group post-test only design, right? Treatment and then measure. But instead, we have this comparison that we can make. So again, the good thing about this is that you're adding a comparison that you didn't have before. You're able to look at these differences between the different measurements of the DV and have some reason to say that there's a difference between these groups that is useful in some way. But the big issue here, really, this reduces issues with maturation, it reduces issues with historical problems and regression to the mean because you have these different comparisons to make. But it introduces all those problems that I've mentioned with selection bias. So, I've talked about the lab groups already. It might be too that, you choose pre-existing law enforcement agencies, and maybe it's the case that the, Seattle, Washington Police Department that you've chosen for a control group is just very different from the Miami, Florida Police Department that you've chosen as a treatment. And differences that you observe between them might have nothing to do with the treatment. Maybe there's a culture of, racist policing in Seattle that there isn't in Miami or something. Not to pick on Seattle, I've just chosen random cities. But there might just be systematic differences between those places in their culture and the types of people that are there that have literally nothing to do with the treatment. So if you're choosing naturally occurring groups, you need to have some sort of confidence that they are equivalent in some way and an eye toward the things about them that might not be equivalent. So the selection differences are a very big deal. And part of the difference here is because you have no baseline to compare them to at the beginning. So you don't know necessarily if these differences between the groups are overriding these differences in treatment. So if you go up again one more step in rigor, you just kind of combine these last two different types of designs. That you have a pre-test, post-test design that you're doing with a control group and a treatment group. So again, two or more non-randomly assigned groups. Let's stick with the Seattle, Washington Police Department and the Miami, Florida Police Department. You're comparing them, but they both have a pretest this time. So you measure shooter bias in a shoot-don't shoot task in Seattle. They get no treatment, and you measure it again later. You measure shooter bias in a shoot-don't shoot task in Miami. do the treatment of racially sensitive weapons training, and then measure it again. And this gives you a lot of purchase to see how things are progressing. It helps eliminate lots of potential issues. You have lots of comparisons. You can compare the not only the differences before and after treatment, but you can compare the magnitude of difference here to the magnitude of difference elsewhere. So if there were just maturation from these, let's say, young police departments getting better, you could see if this difference in maturation was bigger. And then you could say that it probably had to do with the treatment in some way. Or if there's a historical event that might affect the difference you're observing here, you can see the equivalent historical event, hopefully, in the control group and see if the difference that you're observing here is bigger than the difference you're observing here. So this rules out a lot of alternative explanations because you have three different types of comparisons you can make. You're comparing the treatment to the control, the post-treatment to the pre-treatment, and the size of effect between those different groups. So there's three different really important comparisons you can make. But this isn't totally without issues, obviously. You can't totally rule out that these things are going to happen differently because these groups are not equivalent, right? You might still see maturation in one group that's different from another. You might see problems with your measurement affecting one group differently than another. Regression to the mean never really goes away because it's always just kind of a chance thing that might affect your measurement. And importantly, selection and history might interact with one another. So let's say that the officers in Seattle are just more sensitive to news that has a racial content than officers in Miami. Then history might affect them in a particular way that it's not affecting others. Or maybe there's a local issue. Maybe there was a shooting in Topeka that is running on the news in Seattle that makes those officers very sensitive to the types of scrutiny that they're under, and that that Topeka shooting was not covered on the news in Miami. So the Miami officers are not getting that news, and the history there is not affecting them in the same way because of the groups that you have selected. So you're minimizing these problems in some ways, but you can never really rule all these different things out because you are not you don't have total control over everything going on, and you have not used random assignment in a way that eliminates some of these problems. Okay, the last two things that I'm going to go over kind of, again, build on these pre-test, post-test designs by adding multiple measurements pre and post-treatment. So an interrupted time series design, it goes back to our idea of having just one group of participants, but instead of just measuring once before a treatment, we're measuring several times and several times afterwards. So you have your multiple measure of your DV over time. Let's say every first of the month for 4 months, they did the shoot, don't shoot task, then they got the treatment, and then every first of the month for another 4 months, they're doing the shoot, don't shoot task, and seeing if those changes last, basically. So what this does for you is that rather than just looking at one measurement before and after that might be unduly affected by things like regression to the mean or high differences because of history or maturation or something, you can actually look at how things are changing a little more carefully. So if I'll show you a figure in a moment that makes this clearer, but this might have a good outcome of letting you be able to see, well, like, were things already getting better before my treatment, or did the change that I implemented last? Because single measurements can be really influenced, as we know, by lots of different types of random chance and random fluctuations. And if you have more measurements, you might have a better idea of how things have progressed. So let me show you the example that I mean. I know I have a different example here, but let's just still pretend that this has to do with like the differences in shootings. Let's say higher numbers here are like more better scores, more equity, and less of a disparity. I know it's kind of counterintuitive, but let's just say higher is better. So you might measure these disparities leading up to a treatment and see that they are, kind of clustering around a particular baseline, and then you have a treatment here, let's say the racially sensitive weapons training, and then things are getting better. So because of these, you have a little better evidence than if you just had two measurements. Let's say you just had this one and this one. Well, that might be some kind of random chance. Maybe things got better and immediately got worse again, right? But this way you can tell things were pretty stable. It seems pretty likely that the thing that we introduced led to this change, and this change stayed pretty stable. If the shape looked like this, like, hey, pretty flat, bump up and came down, you might say, well, our treatment might have had an effect, or it might have been random chance, or the effect was short-lived and not worth it. It might also be useful to see, like, if you had a slope that went like this, where it was already trending up, and then you measured here and noticed that it kept going up. Well, if you only had these two measurement points, you'd say, wow, our treatment had a big effect. But if you had this whole range of things, you might see that the trend line was already going up. So maybe it has less to do with your treatment and more to do with these other measurement periods that you might not have always had access to. Issues here that, I think more than anything, continuing to list these just shows that even when you have things that rule out these explanations a little bit, you can never totally rule them out. Because it might be that this was a key point in the maturation of your young police officers, or it might be that there's a historical event that happened right concurrent with your treatment and you can do nothing about it. Like, it just happens to be in this period that there was a local shooting that affected things. So you can't ever rule them out because you just don't know what's going to happen, but you can limit them by showing these baselines too and understanding what's going on at the time that you're measuring things. So this is a pretty good design. It tells you a whole lot, but it doesn't, again, rule out everything. And like I've mentioned, you can hopefully provide some different counter arguments for these different types of things based on having all these multiple measurements and more complete explanations for things. Okay, the last one I want to talk about, as you're probably unsurprised to find out now, adds a comparison group, adds a control group. So instead of an interrupted time series, this is generally called a control series design, but it's still just like an interrupted time series with a control group added. So again, two groups of participants, repeated pre-treatment and post-treatment measures, and only one group is getting a treatment. So measure a DV a bunch of times for a control group, measure a DV a bunch of times and a treatment, and measure it a bunch of times for your treatment group. So again, like I've kind of already said, it's an interrupted time series design adding this non-equivalent control group element into it. So again, you're not randomly assigning people, unfortunately, but you are basically doing as much as you can to control things. So the added benefit here is that you are adding this control group for comparison. So you have these same two benefits as the interrupted time series designed with one group that you can kind of evaluate how things are changing, and you can rule out random fluctuations that might happen from just two measurement periods here. But you can really tease apart how the control group stays stable and the treatment group has this big jump here. And then you can really see how these groups are different from this. So having this control group really makes a big difference in you being able to tease apart how these groups are changing. But again, just to kind of be a downer on all of this, you can never still rule out these other things completely. They might always still affect your results, but you are just trying to do as much as you can to rule them out, even though you can never totally say that they have not influenced everything. But you're still, controlling them, identifying them, providing counter arguments for them, and at least now you have this comparison group to say that you are making these claims even more strongly. Okay, well that wraps it up for the different types of quasi-experiments. I'll be back to talk about single case designs and developmental designs for a bit as we wrap up the material before the second midterm. So, if you haven't been already, get in touch with any questions you have for me, and I will, be there to help out. All right, so thank you.